One moment the ocean looks manageable, the next walls of white water are tearing over breakwaters, flooding harbours and swallowing entire parking lots from Southern California to the Washington coast. These are not rogue waves, they are not tsunamis, they are something far more predictable and far more dangerous because right now, as you watch this, the most powerful surf event in years is hammering the west coast, and scientists say the worst may still be coming. From Santa Barbara to Astoria, the shoreline has transformed into a no-go zone. Waves exceeding 18 feet are crashing onto beaches, over seawalls, and straight into coastal neighbourhoods. The National Weather Service has issued high surf warnings for nearly the entire Pacific coastline, with some advisories extending inland as swells push up rivers and estuaries. Roads are submerged, docks are breaking apart, and emergency crews are pulling people from the water who thought they were standing far enough back. In Monterey, harbour officials shut down all small craft operations after waves broke clean over the jetty, dragging unsecured boats from their slips and scattering debris across the waterfront. Highway 1 near Big Sur has closed multiple times as swells surge over the roadbed, leaving behind twisted guardrails and chunks of asphalt. Further north, in Cannon Beach, Oregon, sneaker waves have already swept 3 people off the rocks. 2 were rescued. The third is still missing. San Francisco Bay recorded breaking waves at 14 feet, the highest in more than a decade. Seattle's waterfront saw flooding that reached a full block inland, forcing the closure of piers and tourist areas. In Washington's Olympic Peninsula, entire stretches of beach have disappeared under the assault, with driftwood and debris piled 10 feet high against the tree line. Coastal highways are littered with sand, salt spray has coated windshields miles from shore, and the relentless pounding has left harbour masters scrambling to reinforce every mooring, every piling, every structure within reach of the sea. What makes these waves especially dangerous is not just their size, it is their reach. On a calm day, the tide line is predictable. You know where the water stops, but during a high surf event like this, that line moves. It moves fast, it moves far, and it moves without warning. A beach that looks safe one moment can be swallowed by a surge the next, and that surge carries enough force to knock a grown adult off their feet and drag them into the surf before they can react. This is the reality facing the West Coast right now. Not a distant threat, not a theoretical risk, but an active, ongoing assault by the Pacific Ocean. And to understand why these waves are here and why they are so much more powerful than anything we have seen in years, you have to go back to where they were born, thousands of miles offshore, in the heart of the North Pacific winter. Far out in the open ocean, beyond the reach of coastal weather stations and shipping lanes, deep low pressure systems are churning through the cold December air. These storms are massive, sometimes stretching more than 1,000 miles across, and they draw their power from the clash between frigid polar air sweeping down from the Arctic and warm, moisture-laden air pushing up from the subtropics. The result is an atmospheric engine, a spinning vortex of wind and rain that can sustain itself for days, sometimes weeks, feeding off the temperature contrast and the energy of the jet stream overhead. These storms do not move quickly. They sit, they spin, and they blow. The wind field, known as the fetch, extends for hundreds of miles in a single direction, hammering the ocean surface with sustained gusts that can exceed 70 miles per hour. The longer the fetch, and the longer it blows, the more energy is transferred into the water. Waves begin to form, small at first, but growing with every hour, every mile, every push of wind. By the time the swell reaches the coast, it has travelled thousands of miles, gathering momentum, organising into long, powerful sets that carry the accumulated energy of an entire ocean crossing. But size alone does not tell the full story. The real danger lies in something called wave period, the time it takes for one wave crest to pass and the next to arrive. Most wind-driven waves near shore have periods of 5 to 8 seconds. They rise, they break, they fade. Long-period swells, like the ones battering the coast right now, arrive every 15 to 20 seconds. That extra time means extra energy. Each wave is not just taller, it is heavier, more forceful, and capable of travelling much farther inland. When a long-period wave approaches the coast, it behaves differently. As it enters shallow water, the wave slows down, but the energy does not dissipate. It compresses, the wave grows taller, and when it finally breaks, it does so with a violence that exceeds anything a short-period wave can produce. The surge does not just crash onto the beach. It floods across it, racing over rocks, sweeping up driftwood, and pushing water hundreds of feet beyond the normal tide line. This is how sneaker waves are born, not from freak conditions or random chance, but from the physics of long-period energy meeting a shallow coastline. Right now, buoys anchored miles offshore are recording wave periods of 18 to 20 seconds. These are not outliers. These are the dominant waves, the ones driving the entire swell train, and every time one of these waves hits the shore, it carries the force of a storm that began days ago and thousands of miles away. The data behind these warnings is not guesswork. Dozens of moored buoys, operated by the National Data Buoy Center, float in deep water off the Pacific coast, constantly measuring wave height, period, and direction. Each buoy is equipped with motion sensors that track the rise and fall of the ocean surface, recording not just the tallest wave but the average height of the highest one-third of all waves, a metric known as significant wave height. During this event, buoys off California, Oregon, and Washington have all reported significant wave heights above 12 feet, with dominant periods stretching to 20 seconds. Those are the numbers that trigger high surf warnings, but the buoys are only part of the picture. Satellites pass overhead, mapping the ocean surface in near real time and tracking storm systems as they develop and move. Coastal radar stations monitor wave approach angles and changes in swell direction. All of this information flows into the National Weather Service, where forecasters analyze the data, compare it against historical patterns, and issue advisories when conditions meet or exceed danger thresholds. The system is not perfect, but it is consistent, and it is built on decades of observation and refinement. When a high surf warning is issued, it means the models, the buoys, and the forecasters all agree that the ocean is behaving in a way that threatens lives and property. These are not precautionary alerts, they are urgent calls to action, backed by measurements that leave little room for doubt. The waves are real, the danger is real, and ignoring the warning puts you directly in harm's way. On the ground, the impact is immediate and overwhelming. In Monterey, dock workers have spent the past 2 days reinforcing moorings, moving boats to safer slips, and clearing debris that keeps washing back in with every high tide. The harbour master describes conditions as the worst he has seen in 15 years, with swells breaking over the outer jetty and sending spray 200 feet into the air. Fishing boats that normally operate year-round are tied up, their crews on shore, waiting for the sea to calm. In Santa Cruz, lifeguards have carried out multiple rescues, pulling people from rip currents after sneaker waves swept them off the beach. Emergency responders report that many of those rescued were standing well above the normal tide line, believing they were safe, only to be caught by a surge that raced farther inland than anyone expected. One lifeguard described it as fighting the ocean's momentum, not just its size, the force behind each wave making even shallow water dangerous. Further north, Highway 101 near the Oregon coast has closed multiple times due to flooding, with swells pushing over the roadbed and leaving behind feet of standing water. Road crews are working around the clock to clear debris and repair damage, but every high tide brings a new wave of destruction. In some areas, the pavement has cracked and buckled under the repeated assault, and engineers warn that permanent damage may take months to fully repair. In Washington, emergency officials are monitoring river mouths and low-lying areas where high surf coincides with heavy rain and elevated river flows. The combination of ocean surge and inland flooding creates a double threat, trapping water with nowhere to go and turning streets into fast-moving channels. Evacuation orders have been issued for several neighborhoods, and shelters have opened for families forced from their homes by rising water. Harbors, docks, and coastal infrastructure are taking a beating. Pilings that have stood for decades are showing signs of stress, with some already leaning or cracked. Seawalls designed to handle normal wave action are being overtopped repeatedly, and the constant pounding is accelerating erosion along cliffs and bluffs. In some places, the beach itself is disappearing, with sand stripped away and rocks exposed that have not seen daylight in years. The economic toll is already mounting. Cancelled fishing trips, closed businesses, damaged infrastructure, and the cost of emergency response are adding up fast. For coastal communities that depend on tourism and maritime industries, a prolonged high surf event like this one can mean losses that stretch into the millions, and the longer it lasts, the worse the damage becomes. Yet for all the chaos, there is one persistent source of confusion that spreads online every time dramatic footage of violent surf appears. Clips of waves surging over seawalls, flooding parking lots, or sweeping people off rocks quickly spark talk of tsunamis. The language is often urgent, the tone alarming, and the conclusion wrong. These monster waves are not tsunamis. They are not triggered by earthquakes or undersea landslides. They are born from wind, weather, and the open ocean's relentless energy. Tsunamis are seismic events. They are caused by sudden displacement of the ocean floor, sending a massive surge of water racing outward in all directions. That surge can cross entire ocean basins in hours, arriving as a series of waves that flood coastlines with little warning. The mechanics are fundamentally different from wind-driven swells. Tsunamis carry the energy of an earthquake. High surf events carry the energy of a storm. Both are dangerous, but they are not the same. National Weather Service statements make this distinction clear. There are no tsunami warnings in effect. What is happening along the coast is the result of powerful Pacific storms generating long-period swells that are now reaching shore. The waves are large, the surf is dangerous, and the risk is real, but it is not a tsunami. Understanding that difference matters because it shapes how people respond and what precautions they take. Winter brings a familiar pattern to the Pacific coastline. Every year, storms far offshore raise the risk of sneaker waves and hazardous surf. This is not a rare anomaly. It is a recurring threat, woven into the seasonal rhythm of the West Coast. What makes this event stand out is the intensity and the duration. The storms generating these swells have been persistent. The wave periods have been unusually long, and the impact has been felt across a wider stretch of coastline than is typical. Officials at every level, from local harbour masters to federal agencies, are urging the same actions. Stay off rocks, jetties, and the water's edge. Never turn your back to the ocean. Keep dogs on leash and children close. Even calm stretches of beach can become dangerous in seconds. These are not new warnings. They are repeated every winter, but they carry extra weight now because the consequences of ignoring them have been documented repeatedly over the past few days. The safest choice is simple. Stay clear of the shoreline until conditions improve. That means no beach walks near the surf, no photo opportunities on the rocks, no attempts to test the waves or gauge their power firsthand. The ocean does not care about curiosity or confidence. It responds only to physics, and right now the physics are overwhelmingly in favour of the water. For surfers, even experienced ones, current conditions are being treated with extreme caution. While some are drawn to the size and power of the waves, many are staying out of the water entirely, recognising that the combination of long periods, strong currents, and unpredictable surges creates a level of risk that exceeds even their skill and preparation. Lifeguards and first responders echo that sentiment, describing the surf as some of the most dangerous they have encountered in years. Looking ahead, the question is not whether the waves will continue, but how long they will last. Forecast models show the storm systems in the North Pacific beginning to weaken and shift, but the energy they have already generated will continue reaching the coast for days. High surf warnings remain in effect, and even as conditions begin to ease, the risk will not disappear overnight. It will fade gradually, wave by wave, tide by tide, until the ocean finally settles back into its normal rhythm. But the reality is that this will happen again. Winter storms, long-period swells, and high surf events are part of the West Coast's natural cycle. The challenge is not to prevent them, but to respect them, to heed the warnings, and to remember that the ocean's power is not something to confront or test, but something to acknowledge and avoid. Today, the National Oceanic and Atmospheric Administration continues to track each surge, each swell, each shift in the storm systems that are driving this event. The data is real-time, the warnings are urgent, and the message is clear. The Pacific is not calm, it is not safe, and it will not wait for us to catch up. As extreme weather intensifies and coastal risks grow, the line between awareness and action has never been thinner. Stay safe, stay informed, and stay away from the shore.